MIPS gives customers the freedom to innovate compute, breaking down the barriers of closed and inflexible architectures. MIPS designs configurable RISC-V IP processors that enable efficient data movement for automotive, data center, and AI-based embedded systems. For more information, go to mips.com. So we are here to ask really two key questions. One, this being ARM, you've seen lots going on the IoT market, edge AI market.
Yes.
What do you see as the industry problem? Or this market is, what are the issues that the industry is facing? And how are you going to solve that with your new products?
Yeah. So AI is fairly new in IoT, and so far we've seen it mainly deployed for things like audio and voice sensing applications. But the challenge that is emerging is people want to use it for ever higher performance applications. So we've seen a lot of advancements, and you'll see a lot of demos around the show of people doing things with video and AI, and that drives a need for higher performance acceleration. And it's a complex world and a complex software ecosystem for AI today, and creating a common toolchain and a common software approach for developers has been a key focus for ARM to simplify the adoption of advanced AI into edge devices. So with our launch of Ethos U85 today, we've developed a new neural processing accelerator that can be deployed with microcontrollers or microprocessors, and it brings a common software framework from our previous generations, but it also adopts new transformer models, which are a new form of AI model which is increasingly being used to accelerate tasks like video and image recognition applications. It's actually the technology behind innovations like ChatGPT, but it can be used on much smaller configured models for applications in IoT. And we're bringing that capability natively into an embedded microcontroller environment.
Right, so that's one big issue that you're solving. Tell me about what useful applications do you envision your new products will enable?
So we see our embedded neural processors deployed across a really wide range of applications. And as I said, it started with things like wake word detection and voice algorithms. But as it's moving to these higher performance video applications, that's opening up a completely new category. One of our key partners, Himax, started with things like unlocking laptops. We use face identification using the technology, but they're now deploying that technology into industrial automation, so fault detection and identification on production lines, into areas like retail stock management, looking at how full the shelves are and when restocking is required. And we're also seeing it being deployed into smart home cameras as well. Things like smart doorbells people are very familiar with, but also some other security camera applications or things like monitoring traffic in smart cities. Looking forward, the new transformer models in AI offer some intriguing capabilities. So in areas like, I mentioned that large language models benefit significantly from transformer networks. So it is the case that our partners are looking at applying these large language models, perhaps with smaller language models, for things like natural language processing for devices with a smaller UI. So that rather than being limited to a very structured set of limited words when interacting with a device, you can use more natural language. So, why isn't my Wi-Fi connecting? Or, I want to go for a run rather than click 15 buttons. So these kind of new use cases around human interface are also very interesting.
But some people do say that the LLM not necessarily useful for MCU world.
Yeah.
Do you agree or not?
So a large language model clearly can do incredible things, and it can answer you a question on the understanding of gravity or something completely abstract. And it's clear that you don't need your wall thermostat to answer those questions for you. So we don't need models of that scale and complexity in many IoT applications. but the underlying technology can be very applicable, but trained on a different data set. So I think the underlying technology of transformer models is going to be revolutionary and impactful in IoT. But we probably don't need the sort of scale of a 7 billion parameter model to help us use our washing machine. So I think we're going to tailor it to what is needed for the energy efficiency in the markets that it's going to get deployed.
So for developers to enable those, what do they have to do? I mean, I'm talking about software developers. I mean,
Yeah.
I can see that, the LLM could be useful for natural language, as you said, user interface, right? Without going back to the manual,
Yeah.
you can talk to the machine. How the hell does this work, right?
Yeah, so the development challenge for software developers, has been complex, and particularly it's something that limited number of people really understood. But within the ARM ecosystem, with over 15 million software developers globally, people are forming technologies that are helping accelerate this. So we provide underlying things like compilers to accelerate the models onto our hardware with the Ethos U85, and even software models of the underlying compute, so that you can prototype these models without having physical boards on the table in front of you. And that allows companies like Keekso or Edge Impulse, who are out there building software tools, to help developers go from raw data to a trained model that they can then embed into an embedded device. So it is that full software ecosystem that ARM brings that helps solve that problem of how do you go from just some raw data or some video clips down to something that is useful and usable by the consumer.
Something more tangible.
Absolutely. But it does require developers to come along with their own innovations of where do they want to take the technology. So it's a very exciting space.
What the team did is they took in a Llama 2 1 billion LLM and did a RAG context adaptation on it.
Yeah.
So pulled in all of the user guide for a GM vehicle, so you can actually talk to the car. And it's a bit noisy here, so hopefully the microphone picks it up. But I'll let Patrick demonstrate some what it can do. So it runs voice recognition, automatic speech recognition at the front, runs the LLM, and then runs text-to-speech to talk back to you.
Not too bad. Yeah. So yeah, iDynamics 9.5, and so this is our e-cockpit, as Oliver was saying. So this is our cluster. In the vehicle cluster, and then the IVI infotainment portion. Separate OSs is running Linux right now, and then real-time operating system off the M. So basically, these are hardware separations. So from a safety concept, that's exactly what you want. And this is hypervisorless. So yeah, so no hypervisor involved,
It's a
but it's still
hardware-based,
it's hardware-based.
Yeah.
So this could crash as you're driving down the street. It could crash, but this would remain up for the driver, and so then you just drive to the side of the road or go get maintenance to get everything fixed. It's also got different. It's got a safety island, so it's an ASIL-B SoC. From this is like our first iDynamics SoC that has that in it, as well as hardware separation with a HSM IP as well. And then, like you were saying, the driver wants to keep his hands on the road all the time, so you just talk to it now, and you say, "Hey NXP, map." And then you can talk to it and say where it's going. We're not that far yet.
But it's a prompt. It's a prompt map. I mean, can you say, can you show me the map?
Yeah, you could change those prompts, right? Maybe OEM will maybe make a different prompt. AGM or hey.
Yeah.
Something, right?
Right. But the idea is that it's more natural
Exactly.
speech rather than defined keywords.
Yeah, because instead of just saying, hey, give me a map, and it might not recognize it or something, but this will recognize that keywords and from a different languages too, it's going to be able to pick up the different iterations of, let's say, a Hispanic guy with a little accent. Well, actually in the U.S. a Southern person, right? With the different accents we have, so it picks all that up.
That more natural conversation with the car, more natural control of the car features. We're betting on the foundation models and the LLM running. And but I mean, everything else that's more traditional in terms of touch control, in terms of the UI, that's also still there. So now with LLM, you're adding another level of ease. I mean, for me, it's like you travel a lot too, so you pick up a rental car, they're all different.
Yeah, exactly.
So I wanted to get in and say, just connect my phone so I get my maps up.
Yeah.
Just tell me where my windshield wiper is.
Yeah.
Is it on the left? Is it on the right? Where are the lights on this car? Where's the
Basics.
just the basics. So
It's more
where's the
conversational AI. That's kind of how I refer to it. Conversational.
Yeah.
It's much more easier.
Right.
You know, I mean, it's generative. I think is what we're
And this is on the cockpit side, so we're pushing it into the cars because we see that as this device is meant to run at that level. On our other iDATAM X9 products, where we get into more the medium range, let's say apps processors, you can run it on other controls, into appliances, into your thermostat. It's smaller and smaller, but you want to be able to say, I'm feeling cold, can you warm it up, instead of saying, hey, Alexa, set the thermostat to 22 degrees Celsius. Like, instead of playing that specific command lane of what you're saying, you say, I'm feeling cold, increase the temperature. Hey, it's kind of hot inside the house. It understands the context and will set it to where it is, so that more natural conversation that you can have with your devices, so that you don't need to become an expert in creating command language for them.
Very good.
Yeah, we're pretty happy with it. Yeah.
Yeah, this kind of AI that makes sense. The great thing about MIPS is that you guys have really changed the business strategy and business plan. But the big deal is RISC-V, isn't it? So tell us what you're showing here and what problems are you solving?
Yeah, okay. Thank you for that. So yeah, you're absolutely right. So about 2 years ago, we pivoted the company from MIPS ISA to RISC-V, and then today we're showing off some of our first RISC-V based processors. So what we're showing here is a demo of our PAE 704. It's our first out-of-order RISC-V processor, and it's also automotive certified as well. So this is an ASIL-B capable processor. And what's great about MIPS and traditional strength of MIPS is that we've been a multi-threaded processor company. So we've been making multi-threaded CPUs for a long time, and now we're doing that as well on the RISC-V side. That's correct.
So tell me the advantage of multi-threading.
Yeah. So multi-threading enables you to do a lot more computing efficiently. So instead of sitting around waiting on I/O, you can do other tasks, processing tasks, right? So this enables us to do these secondary tasks efficiently without having to put multiple CPUs down or more than one CPU down. So it gives you a lot better compute density, gives you a lot better compute power advantages as well on the side.
So what would be the most useful application you would envision with this multi-threading capability?
Yeah, so we see a lot of traction for multi-threading in automotive specifically. So on the ADAS side is what we're showing here in the demo. So yeah, in the ADAS, if you're interfacing with a camera, for example, you have data packets coming in, you're processing those packets. That's an application that we absolutely see being able to take advantage of multi-threading, amongst many. Networking is another great traditional application that leverages multi-threading very efficiently. And then as we're moving to AI, right, everything is AI now. We see a lot of trends in the way those applications process data, as to like networking as an example. Lots of heavy data movement, which is also something that MIPS has been very good at for a long time, and really lends itself to multi-threading.
We are here with Matt Mopian at the Silicon Labs, and we're actually coming around and asking two really important questions. Number one, what do you see as problems on the IoT or Edge AI market today? What problems exactly are you solving with your new products?
Okay, great. That's a great question. So the new product I'm talking about today is our XG26. And this device is really targeted towards IoT edge devices, in particular Matter devices. So really the problem we're seeing there, and Matter is a relatively new standard. It was developed and released about 18 months ago. And with any new standard, they're going to go through an evolution. And one of the issues you see is, the biggest issue is you have a code size growth. And so what's not uncommon to see is, over the years, the size required to grow to where it may actually exceed the memory capacity of these edge devices. these edge devices are constrained. What I mean by that is there's not a lot of flash, not a lot of RAM. And so what this does is this device doubles the amount of flash and RAM from our current generation devices, and it also adds more I/O. So what we're solving is really around future-proofing customers' products that are launched. So if I look at some of these products that are launched, if I look at a phone or a PC, those have a product life cycle of 3 to 5 years. If I look at something like an LED bulb, that product life cycle is 10 years. So what these manufacturers don't want to happen is for this device to become obsolete before the end of the product life cycle. So by having enough flash and RAM and resources in this, especially for new standards like Matter, we're sort of future-proofing these devices. So when they roll them out, they'll continue to evolve as the standard evolves. So not only do we have more memory capacity, but we also have a lot of advancements in the security side. We know that security is always becoming an issue, and we're seeing it more in the IoT space, where there's actually regulations that are making more stringent security. So it's a lot more than just protecting the data over the air. It's about how do I protect that device? And so, these are devices, a very secure device that could also, the security can evolve as the Matter specification evolves. So that's I think one of the biggest things we're solving is really helping our customers to future-proof their products so they don't become obsolete before their product lifecycle ends.
I have one follow-up question. How much memory?
So in this device, it has 3,200 kilobytes of flash, so a little over 3 meg, and then 512K of RAM.
And that's enough for future-proof?
Yeah, so if you look today, the Matter specifications just over 1 meg of flash and about 160K of RAM. That 1 meg of flash does include room for the over-the-air update. So really, we're really substantially, almost 3 times. So we're really going much more beyond than what they're going to require. But the extra RAM also allows for more applications. So one of the other things we're starting to see is a lot more AI at the edge. So this device actually has an AI accelerator in it, so we could actually offload a lot of that inferencing, that stuff they're doing at the edge from a computation standpoint. We could offload that. And what we're also seeing is for applications like audio, in order to get better resolution, it's very RAM intensive. So now with that 512K of RAM, not only do you have enough to run the stack and the application, but you also have enough RAM to really do these higher end audio inferencing samples.
Gotcha. Now, let me ask you this. So you mentioned edge, you mentioned connectivity. Tell me that what would be the most useful application, not smart, most useful application do you envision this technology or products will enable?
Yeah, that's actually a hard one because if you look at what Matter addresses, there's a lot of applications. You have things like LED lighting, you have sensors. I think one of the ones I'm personally most excited about is applications that require much more I/O. For example, let's look at locks. Surprisingly, locks require a lot of I/O. There's stuff in there for motor control, for all the sensors. There's a lot fully engaged. So there's a lot of I/O in these, and they typically exceed what a standard wireless SoC can deliver. This new device, we have up to 64 GPIO and 4 dedicated analog in, so 68 I/O. So what this means is now you can, instead of having like a wireless SoC and an MCU, now you actually do that integration into a single chip. So it really just helps you, deliver more advanced applications, more integration with a single chip, reducing the cost and the complexity.
And what would that be useful to consumers? Is that cheaper or?
For consumers, hopefully they'd be able to get things at a lower cost. Obviously, from a developer standpoint, it's easier for them to develop things if it's less complicated, and it's going to make them more competitive.
So we announced our APXM 6200 CPU yesterday, and so there are 2 levels of problems that we are trying to solve. So first, there's a RISC-V ISR kind of a challenge. There's an apparent trust issue in the market of moving away from an ARM-based design into RISC-V. So we are trying to ensure that there is customer confidence, there is an ease of migration from an existing ARM-based design into RISC-V ISR. So we've been working on a number of steps, working with the ecosystem, but also providing a lot of different ways to lower that barrier to switch from an existing ARM architecture to RISC-V.
The second challenge that we see in the market, particularly in the consumer and industrial devices, which is where our product is focused at, is the market is really cost sensitive. But the performance needs of this market are also increasing. Especially you have number of sensors getting attached to consumer devices, and because of that, proliferation of data and AI use cases coming in these devices as well. They need more performant CPUs, they need more performant processors in a very, very small form factor, so that silicon costs are under control. So what we are bringing is a really performance-dense CPU. In addition to that, Imagination has also got the GPU, which is again a need for this market, the graphics interface, the human-machine interface that we have. And we are trying to combine our CPU and GPU to bring better performance in these devices. So you don't have to over-specify your memories, you don't have to over-specify your internal networks, because we reduce the amount of data, particularly in the graphic use cases, that is going to the memory, that is running on the device itself. Thereby you can create another efficient silicon platform, which is cost effective, but yet get the performance out.
Let me ask the fundamental questions. Why do people want to move from ARM-based solutions to RISC-V?
So RISC-V is mainly driving two things in the market. It's democratizing compute, and it's also accelerating compute. So ARM has been a dominant player in the CPU space. Today, the industry doesn't have a choice outside of ARM, and that according to me slows down the innovation. Competition drives innovation. Without competition, there is little innovation. ARM V8 to V9 architecture update took about 10 years. Similarly, having a monopoly in the industry is not liked by the industry. There are commercial reasons for that as well. So what RISC-V is doing is democratizing compute, and it's also accelerating compute, because many companies are now putting effort into building better CPUs, more performance CPUs, lower power CPUs for different use cases, and that's what's kind of driving this competition, driving the industry to move away from ARM to RISC-V.
My second question, what useful applications do you envision that come out of your new RISC-V processor combined with graphics?
Yeah. So our product we announced yesterday is an in-order performance-dense CPU, which has the capability to run Linux and Android. And when put together with our GPU, which is the industry-leading GPU, we are able to bring Android and Linux graphics application into market. So things like set-top box, DTV, wearable use cases, industrial use cases, voice-activated home devices, all of them which have some level of intelligence, but also has graphics needs where you need a human-machine interaction. These are the type of applications we believe our CPU and our GPU will go in together.
So having the install base of GPU actually helps to bring RISC-V into the world.
Exactly. So it helps because we have the customer base. We work with these customers to understand their problems, and these problems are the ones that we are trying to solve with our CPU and bringing alongside our GPU.
And what are these problems?
So problems, like I said, in these cost-sensitive markets are around cost sensitivity, data traffic on memories. They don't want bigger memories to sit alongside system. So how do you reduce data traffic? How do you reduce memory footprints, memory traffic? So all of these things are needed. Plus, at the same time, increase performance as well.
When do you plan to actually merge GPU and CPU together at one point? Integrate, or it's going to be separated all the time?
It will get more tightly integrated. Whether it gets merged into one unit, hard to say. There are fundamentally two different things that these devices do. See, when you have to run an operating system,
Yes.
you need a CPU. Right? And on top of the operating system, you can have tightly coupled applications that could be running, whereby you would see the boundaries getting blurred. But still, a CPU is needed in the system. It fundamentally drives the operating system. It drives the security story.
So it's basically uses the Synaptics SL series of processors. It has a common I/O card with connectivity in it. You can have Wi-Fi, Bluetooth, all as a package, and then you can replace the different compute modules, going from low, mid, high. ARM-based processors with NPUs for various different IoT applications. All these different segments. So that's our focus at home. So runs Linux, runs Android, and so the way we are trying to differentiate on this one is like the AI story on this Chuko. We are opening up our entire AI toolkit. It's on GitHub. Anybody can go download. We have like very detailed documentation because this edge AI, right? It's a mess. Like too many things going on, right? So we are trying to bring some order into how do you do edge AI.
Excuse me.
Yeah.
Why did you say Edge AI is a mess?
Yeah.
What do you mean by that?
So in the data center context, right, we kind of know the story. Cloud, models, training, GPUs, the entire ecosystem is built for that and around that. You come down to the edge, it's not any longer just a GPU story, right? We are beginning to have NPUs, DSPs, CPUs, FPGAs, it could be anything. So the question is like, which vendor has what kind of tooling? And the problem is, most of the vendors, you go to them, the experience is very custom, very proprietary. We want to change that up a bit. And we are just opening up our entire GitHub.
But this development board is the hands-on platform that people can use to try it on.
And we have an early access program right now. You can sign up. We'll qualify the request and then we'll ship a board.
Plays to the strengths we have, right, which is the processing and the connectivity. And
That's your thing.
yeah, exactly.
Yeah.
So and people want choices, right? And so what we do is they buy this base board, and then they can swap out any one of these processors, like you said, the high, mid, low, and then any combo device you can put in the back. That comes from us.
It's actually an
and it just
IoT
works.
system.
Yeah. So it's moving in the right direction. Like everything is coming together.
What I want to know is that everybody talks about Edge AI.
Yeah.
Right? And the range of definition of Edge AI is very broad.
Yes.
And what problems do you see in the current Edge AI industry, if there is such a thing? I mean, what are the things that are missing? What are the things that you think that it's inconvenient to the developers? What are you seeing? Your observation.
I think the edge AI market is quite fragmented, to be honest. Like I was just walking through the show floor,
Yeah.
and I'm looking around and I see AI is plastered everywhere,
Exactly.
right? And I was actually remarking to someone, how's a developer supposed to know who to talk to, and what will that experience be like, right? And so we were trying to rationalize that the messaging to the developer community needs to be very simple, and don't overload them with too many choices, and yet think about their journey on what they might want to do to bring a product to the market. The IoT market at the edge was fragmented to begin with already.
Exactly.
And now when you throw AI on top of it, it gets even more muddy. And so I think anybody who can keep the messaging crisp, think about AI natively, and make it frictionless, can go a long way in reaching out and resonating with developers. Some of it is in our products, right? And that's why, like, when we offer a range of processors, we are keeping in mind that this development platform that we have can actually handle all of them. So it's not like different variants and that everybody has to get comfortable with each variant. this is architected in a way where you have a common baseboard and you can swap in any processing that you need depending on your application's requirements. And so that part from a hardware perspective, and on the software side, as I was mentioning, just having it be completely open and available to the developer so they can actually see what is going on. So having the SDK on the software side be unified in a way that is meaningful and yet have it be open source, right, makes it easy for them, and there's a level of comfort that they will have in terms of using it and solving their problems. You know, there's a transformation of synaptics that is happening because of all of the move towards having this Astra line. And we are trying to emphasize ease of use, self-service, that kind of a model, even with our website.
Yeah.
So if you go to our website as of yesterday, you know, and especially as you follow the links on Astra, you'll see that it's much more seamless to navigate through it. And it basically allows the user to navigate a website to come to their answers very quickly.
So yesterday we announced the CEVA Waves Links. That's a new platform IP offering from CEVA, which combines multiple wireless protocols. We already have IPs for Bluetooth, Wi-Fi, UWB, all the 802.15.4 variants, Thread, Zigbee, Matter. We're now combining them into one unified platform, which would have Bluetooth, Wi-Fi, UWB, for example, as one combination or any combination of those standards. You may have seen companies like Qualcomm and Broadcom, they are starting to offer those multi-wireless protocols solutions out there. The market is expected to be around 16 billion combo wireless devices, having at least two wireless protocols by 2028. So it's a huge market. Already many of the CEVA customers are licensing more than one wireless protocol from us. It's about 1/3 of the customers last year that have bought more than one wireless protocol from CEVA. So it made sense to offer this CEVA Waves Links new IP platform offering. We already have one customer for that platform. It's an OEM that decided to make his own chips. He bought what we call the Lynx 100, the first platform in that family. And that family includes the Wi-Fi 6 1x1 and Bluetooth 5.4, which is for low power IoT applications. The next CEVA Waves Links platforms may include Wi-Fi 7 and a different flavor of Bluetooth and UWB and maybe Thread and Matter for smart home and so on. So it's very flexible. Trying to address the main questions that you raised. So the problem that we're solving with the CEVA Waves Links, first of all, it's a unified solution. So it already takes care in terms of being future-proof for all the wireless standards. So we take care for the Wi-Fi, the Bluetooth, the UWB, the 802.15.4 in a unified manner, simplifies the integration of this subsystem design into your chip, basically. So you're already covered for whatever applications, wearable, smart home, industrial IoT. It's already taken care of because everything is solved inside. There is the coexistence problem between the different wireless protocols. So for efficient concurrent communication, you need to take care for the coexistence of those Bluetooth, Wi-Fi, UWB. So we take care of all of that. The coexistence interface is a big problem in these multi-protocol devices. Then we have the lower cost. You can use just one RF module perhaps. If we are using Wi-Fi and Bluetooth at 2.4 gigahertz, for example, you can use just one unified RF, lower cost, lower BOM. This whole wireless subsystem becomes much simpler and lower area, lower cost in general.
So other companies are not providing this combined, combo IP for all the wireless?
No. No other company is providing this comprehensive set of wireless protocols together, certainly not in a unified manner, which takes care for so many use cases these days.
What if I don't want all of them?
Okay, so that's where the customization comes into place. So I mentioned the Lynx 100, which is a specific configuration made for a customer. Wi-Fi 6, 1x1, Bluetooth 5.4. You may want different things. You may say add UWB, or I need 2 Bluetooth perhaps channels inside. So we can do that for you. We will have the Lynx 200 and the Lynx 300, the future platforms that will come up, addressing any configuration that you or the customer will want, of course.
So you're solving really the connectivity issues. That's what you're saying.
We're solving the
That's a big
connectivity.
issue.
Anything that has to do with a short-range connectivity, Wi-Fi, Bluetooth, UWB, related protocols, all that is being solved with that program, with that platform.
What do you envision? If you have so many connectivities in your new, you're enabled by your new technology,
Right.
what is this kind of most useful applications can you imagine?
So wearables,
Wearables?
certainly, from our point of view,
Yeah.
at least. I'll give you an example. In Bluetooth, Bluetooth earbuds and headphones, we have a share of 50% of the market.
5-0.
50% of the market of the non-Apple earbuds and headphones out there. So anything not Apple, half of it is powered by CEVA Bluetooth
Gotcha.
inside. There's one example here of Boat. Do you know Boat, the company?
Both?
Boat.
Both?
Most people don't.
I don't, yeah.
They are the #1 wearable company in India. But they are also the #2 wearable company in the world after Apple. In terms of volume, it's a lower cost product, but huge volumes. These headphones, which were announced 2 weeks ago, the Boat Utopia Nirvana, they employ a chip made by one of our customers that has a CEVA Bluetooth inside, CEVA Audio DSP inside the same chip, and our 3D audio software, which is head tracking and 3D audio renderer. So these are branded as the first spatial audio, 3D audio headphones in India, made in India. And it combines technology from our Connect, Sense, Infer. So it has our Bluetooth, it has our audio DSP, and it has our sensing software in terms of 3D audio and head tracking software. So a very good example of how multiple technologies succeed. So wearables is very big.
Big.
Yeah.
So can you explain one more time that how I understand the connectivity part, I don't really understand how the sensing actually comes into play with the headphone like this.
So the sensing in this case is the head tracking, which means the accelerometer and gyro, which are in here, are detecting the head movement.
Yeah.
And position the audio accordingly. So if I'm watching a movie here and I turn my head, I will still hear the audio coming from here. Same thing from here. So I would really, it would be like real life. If you're talking to me and I'm looking there now, I still hear you coming from there. So this is the realistic 3D experience. So sensing here is head tracking, the motion sensing in these headphones. Connectivity, of course, is connectivity, and Infer happens on our audio DSP, which is used also for some AI use cases, such as noise reduction using neural network, for example. So just a good combination for multiple technologies.
So the key point first is what we have today is samples of this technology that is the most advanced ENVM technology ever released so far.
ENVM?
Embedded non-volatile memory.
Okay.
So embedding the non-volatile part of the memory that is used by the CPU to execute the firmware inside the chip. And so this is a sub 20 nanometer. In fact, it's an 18 nanometer technology. FDSOI based, and what it brings is that it's higher integration. So far, what you have seen on the market is 40 nanometer. Now some people come with 22. This is an 18. So this means that you have a higher density. You can have more features inside the die for the same area. You have higher digital density, higher SRAM density, so you can get more memory inside, but also more NVM. So larger code, firmware code from the customers can be stored inside this chip.
That's the first big advantage of the technology. The second one is that because it's a more aggressive node, you have a better performance. So you can run at higher speed. You can also get a better ratio between performance and power. And this is also what technology can bring, moving below 20 nanometer node.
Right. So what problems are you solving with this new super duper MCU that you're coming up with?
So we are solving one of the key issues, which is customers always need more performance and more integration. I mean, more IPs, more connectivity. We can bring a lot of timers, we can bring high-end connectivity inside the chip at a price that is very good, because that's what technology brings, more digital density, higher gates inside the silicon. It also helps to support larger applications because the software is increasing in its size, especially new application, AI-based application. AI at the edge requires large software and large SRAM because we are handling a lot of data. And this was not possible on older technology nodes because of the size and the power that brings this, and the integration in a more advanced technology allows to do this in a microcontroller, which is a highly integrated chip. You have NVM again, non-volatile memory, you have SRAM, you have the processor, you have digital IPs, you also have analog. The technology brings 3-volt analog features, ADCs, analog to digital converter, digital to analog, comparators, op-amps, IOs, general purpose IOs. That's the beauty of microcontrollers. Full integration, digital, analog, mixed signal chip,
all in one
die.
What's the, if you look at what's available in the market now, not just from ST, from your competitors, how does this rate? I mean, how far ahead are we talking about now?
If you compare to today, what is really the most of the microcontrollers are in 40 nanometer technologies. So when you compare this 18 to 40 nanometer, you have a ratio of 2.5 on the non-volatile memory size. So we are 2.5 times smaller, or you can get 2.5 times more memory in the same size. Digital density, you have a ratio 3. So 3 times more integration of digital peripherals inside the chip. You get 50% higher performance compared to 40 nanometer today. So that's the ratios we see versus what is available on the market. Few competitors started to announce 22 nanometer technology, but this technology is denser than what is announced today by these competitors.
You talked about the non-volatile, embedded non-volatile. You're talking about embedded phase change memory, correct? What's the size of the memory?
I cannot comment on the size itself. What I can tell you is it's 2.5 times smaller than 40 NVM. I can say that it's a very small bit cell, and it's a very robust bit cell because phase change memory has been qualified by ST at 28 nanometer node for automotive applications.
Right.
Here we speak about an industrial MCU, and industrial mission profiles are very aggressive. They are very demanding. And so the fact that we qualified this technology on automotive now is reused in industrial. So we have already demonstrated robustness. I mean, high temperature operation, cycling, attention. This is qualified already with very aggressive profiles.
Let me ask you basic questions. This is not MPU. This is MCU.
That's correct.
What is the difference here?
So the big difference first is, we integrate the memory. If you take an MPU architecture, you have an external DRAM, you have a DDR interface, you have an external power management IC. Here it's a microcontroller, so it's based on first an ARM Cortex-M type of core. You have the memory inside the chip, you have the analog embedded, you have the power management embedded. That's the main difference.
So does it simplify for the designer?
Oh yeah, for the customers, obviously, managing a microcontroller is much easier than a microprocessor. You don't have to take care of all these external components, memory, power management. The management also, of DDR at high speed is something that is challenging at the board level. You don't have this problem here. You have everything on one time.
So what would be the most useful application you can think of that this new MCU will enable?
Mainly industrial applications, that's the first target. So factory automation, all type of complex application requiring high performance, so high speed CPU. These applications can go up to 125 degrees C ambient temperature because we can support a very high temperature on the die. And all applications which require again large memory sizes. So complex type of algorithm, AI-based AI at the edge, for sure. This would be very useful for these applications.
Can you explain a little bit about this new opportunities? Give us examples.
I'll give you an example. In microcontrollers, on the previous nodes, like 40 nanometer, we were limited by the max frequency we can reach. In ST, we reached a very high frequency, like 600 megahertz on 40, but the problem is, when you stay on older nodes, the power requires to run at high speed is much higher. Mm-hmm. So you end up with a situation where you have to make a trade-off between performance and power. You end up in packages for microcontrollers are easy to use. I mean, they are not very high-end packages where you need also to cool down a chip, things like this. So this technology opened the opportunity to run at a much higher speed without moving to this problem of power dissipation. And so being able to provide a CPU performance that is unmatched so far. So you can think about applications, embedded applications that could not be done with microcontrollers before.
And that is more of an industrial market, you think?
That's our first target today,
yeah.
Because the industrial customers and applications require high CPU performance.
This is talking about the factory automation, or
factory automation is a good example. Yes, yeah. Factory automation is one. But also AI is really changing the game because the size of the models you want to implement at the edge, the requirements of SRAM content is really changing now. And this is another opportunity for us with this technology to bring the next level of high memory integration on one die.
You just announced it's called MCXW, right?
Yes.
What problems are you seeing in the industry, and what specific problems are you solving with this new product?
That is a great question. So first of all, let me just preface that the MCXW is our new series of microcontrollers that's part of our MCX portfolio and brings wireless connectivity. So now going to your question about what are some of the key challenges. In the IoT space, building secure connected devices is not a simple task. There are a lot of elements around the wireless connectivity and how to implement and deploy that, how to implement and deploy security, and how to bring differentiation to your product with the types of user experience in your application that you provide. So what we really targeted with our MCXW Corp series is to provide and equip developers with tools to be able to navigate how to create these devices. So we're bringing more of the functional blocks that help enable them so they can develop quickly and they can focus their energy and resources on how to innovate. So what I mean by that is we're doing the processing, we're doing all the wireless connectivity stacks, we're also implementing security. So as an example, to build a Matter device, we can support the different device types, all the way from sensors up to door locks or thermostats or hubs, using the MCXW as the main component for connectivity, but they can also add one of our processors from our MCXW portfolio or our I.MX portfolio if they want additional stuff. And then all of that is enabled with security and the tools that you need to deploy the right level of security for the intended use case. So that's one of the things that we are bringing. And then you have a second question.
My second question is, what useful application do you envision this MCXW will enable?
So at NXP, we talk a lot about the autonomous home or the autonomous building. And what we mean by that is we need homes and buildings to be smarter, to deliver the right experience to consumers or users, and to address some of the challenges that the industry has around how do we drive energy management to have lower carbon footprint, how do we deliver more secure experiences, how do we take all this data that we now have access to and create something out of that. And I know that you and I have mentioned this before, I say this all the time, many people have smart devices, but having an intelligent home that it's personalized to your experience, that's the type of application I think that we at NXP are really working to enable and make a reality.
Yeah. Give me some examples then. What would the consumer find useful in that sense?
You know, when I think about, for me personally, like energy management is a big deal. Like I want to have not just reduce costs, I mean, and I care about the environment, but also I care about money, right? And so having my house be able to respond and know when I'm in the house what I want, and I'm very different than my husband. He will turn off a light going up the stairs. I want the light on, I'm going to go up the stairs, I need to get something and go back down, I'll leave it on and then go out. He'll turn it off and then turn it back on. So I want a personalized experience that doesn't require me to pull out my phone. I don't even want to talk to it because sometimes it doesn't understand me, you know, and it does the wrong thing. So I think that that's the type of experience because then I get more value out of my smart home. If I can manage the energy personalized to the way I need to live in that space.
Hello everyone, my name is Raj Kumar, so I'm the Director of Software Engineering from Renaissance Electronics. Today I'm going to talk about QuickMix Studio. It's our online cloud-based embedded system design platform which allows our customers to graphically design their solution on the cloud by dragging and dropping the design blocks, the MCUs, the sensors and the connectivity module on the cloud. And once they put the pieces together, the platform automatically generates the base software and the application needed for the use case. It will significantly reduce the design complexity in the system design process and also speeds up the time to market for our customers. So they can concentrate on the key value proposition of designing their application rather than focusing on how to put the hardware and software together. So this platform handles that solution. It's completely hosted on the cloud. We are deployed in multiple regions across the world. So users or customers coming from different parts of the world, they will be routed to the nearest data center for better user experience.
So it addresses complexity in the market.
On the system design. Traditionally, in a system design process, the customers always design on the hardware and then go and design the software. This platform unlocks that. So you can now start both software and hardware simultaneously, and you can use our platform to design the solutions without having any knowledge of what the MCU package we have, without any knowledge of the software package. So the platform encapsulates all the software needs for your use case. So you can start directly on your application, which is your value proposition, right? So we will take you from step 0 to step 8 using this platform. So the step 9 is where you will contribute on your use case application, and step 10 is where you publish the product.
So our second question is this. So you've talked about the solution itself, the technology. What are the specific useful applications for it in the marketplace?
So today we are showcasing the IoT applications. You can design any type of IoT applications, and we are expanding all the product portfolios of Renesas, and we are also working with strategic partners who are going to bring us the technologies where we don't have in Renesas. They're going to be supporting us. So here you can see we have our 3 partners, Agilcam, TDKS and Ashram. We are also talking to many more partners who are going to bring their solutions and devices into the platform. So for our customer design needs, we will provide all the offering from the microcontrollers to microprocessors, all the components, sensors, connectivities. It will be a complete ecosystem.
So let me reframe that question in terms of which specific industry sections, what kind of products. I know you've talked about IoT. But IoT can be generalized. Do you have maybe examples of?
So today I can show you how, let's take a simple example, how to design automatic monitoring, asset monitoring system, right? So what you need is a low power MCU. you need a sensor, temperature and humidity sensors, and you need a connectivity. Let's take a BLE, right? So I will show you how to put these three components together within a matter of minutes, how a concept which we are discussing now will turn into a full working solution. Let me demonstrate that here. So here you see when you launch the Quick Connect Studio, every user will have the unique workspace on their browser. On the right side, you will see all the devices we currently support. So I'm picking up our low power RH0E1, which we launched today. I'm bringing the sensor. I'm attaching the Bluetooth. And you can see how I'm doing as putting the Lego blocks together. And then when I build, the platform now generates me all the base software package and the reference application for my use case. So within a matter of minutes, I can put together a concept to a full working solution. So it's not limited to only IoT, it can be expanded to cover any complex application running both on the microcontrollers and microprocessor space.
Okay, so you were just telling me this new product that you just announced. Tell me what it is.
It's called PSOC Edge, and it's a high-performance, machine-learning-enabled microcontroller.
Okay. And so the key question we're asking everybody here is that what problems do you see in the industry today, and what problem exactly this new product is going to solve?
So there's a lot of problems this product solves, and if we look at it from a developer perspective, so there's a couple things here. One is that it allows or enables those developers to add a set of capabilities to an existing product while maintaining kind of a cost envelope of an MCU-based design. Another option for them, however, is to expand the capabilities of within their existing portfolio by adding a range of machine learning, let's say, functionality to their end product.
So, you know, as we go around, we see like AI or machine learning, the letters are plastered everywhere, right?
Yep.
And this particular MCU that you're talking about, it's something, how is it different from other people's approach to the machine learning?
That's a great question. So we really put a lot of machine learning performance into an MCU that traditionally you would see more in an apps processor or frankly even in the cloud. Okay, so that difference shows up in terms of system power, system privacy, the security that is enabled, as well as the developer experience. So the developer experience that we're bringing to market includes a complete integrated tool chain that we call Modus Toolbox, but within Modus Toolbox we have a machine learning suite called the Magimob suite that is end-to-end machine learning from I want to collect data to model out and deploy it on the device.
And this is, we are essentially talking about industrial applications.
So there's a wide range of industrial, consumer, and I'll say broadly IoT applications. An industrial application might be safety related, for example, or quality related. So defect monitoring, and that defect monitoring might be related to vision. Mm-hmm. So watching products as they come off the line, are they manufactured per requirement? Or frankly, it might be towards quality. An example that our Magimob team has around machine learning is using audio to detect the quality of a weld, for example. So of a weld, welding in a manufacturing environment. So it turns out that the sound that was made during a weld, an expert welder can detect if there's a defect. Well, now we're using machine learning to detect through the audio signature of a weld operation if there's a defect in the weld.
But that requires collecting data.
That's right.
Yeah.
Absolutely. And in that case, that's exactly, we worked with a customer on that. They collected a manufacturing site that is welding parts together and collecting a lot of data to create models that would detect an abnormality in this welding process.
All right. So you already touched upon some of the examples, but we would like to ask, not smart, but useful application you can think of that enabled by this new product.
Okay, I think if I start at the top level, I think one of the most useful things we'll see out of this is a reduction in the human-machine barrier, if I put it like that. And if you look at maybe, for example, today around the smart home applications that are trying, or maybe your car also, that are supposedly using machine learning, and maybe it's an audio application, so voice activation is a very common one these days, right? If we end up having to change the way we speak because the machine doesn't understand us, that's not really machine learning, right? It's human learning. We are learning to adapt to what the machine needs to hear from us to take action. And I think this class of processor will enable those machines to be more intelligent and that communication to happen locally at the edge instead of going to the cloud. So, and again, if I come back to this voice one, a very simple use case would be I would issue a request or ask a question, and instead of 1 to 3 seconds of going to the cloud, processing, and then coming back in some random way with the response, that can happen almost immediately on the device. And I think that is an improvement in terms of how we interact with the machines around us.
Does that mean that your MCU is capable of running large language model?
That is a great question, and the answer today is no. But I do see that coming to the edge at some point in the future.
Yeah.
Embedded systems are getting progressively more complex.
Yeah.
And as they're getting more complex, you're starting to see people talk about AI getting into it and many other phenomena, right? But while we see the advent of new aspects coming in, the fundamentals of the embedded system still remain the same. It's a system which is elegantly designed, where power, cost, and functionality, reliability, safety now coming in with a level of automation, multiple sensors and sometimes processors, controllers, they work pretty seamlessly. And I think just talking through and thinking through designing those systems in these new formats with new cores, new tools, I think that's key. And what's happening is, earlier there used to be a very general aspect of embedded systems. But what we realized is generality does not work for embedded. To make something optimized, you have to be application specific. And I think bringing that application orientation, linking the workload to the system, linking the workload to tools, ideally open source tools, down to being able to say, okay, what should my system look like? How many CPUs do I need? What kind of CPUs do I need? What kind of peripherals do I need? What kind of performance and latency do I need? I think that's where we are starting to see our customers wanting to reimagine how they design the system into more efficient.
Another big thing coming in embedded is going to be operating systems. So again, you cannot scale the IoT
without
with bare metal.
Yeah, right.
The cloud can't interface with bare metal.
Okay.
You can't run machine on bare metal. Like it's going to be OS based. And if you even walk around the show here, like most end devices are still and MCUs, not MPUs.
Right.
MPUs have Linux and all the things, but in embedded, there's still a tremendous amount of legacy thinking around bare metal optimization versus OS scalability and stability and security. So OSs have to go mega, and they're about to in embedded. We're in embedded kind of trailing on the Moore's law edge. Yeah. But we're starting to get to the point now where we can offer enough clock cycles and memory and all the things to make OS overhead kind of fall into the noise. So that's a big thing that's got to happen.
And the objective here to run OS on MCU.
Yes, as a default, as the only way. Instead of bare metal or OS, it should just be OS.
So, but you got to work with the embedded OS guys then.
Yeah, we do.
You all do.
We have been for a while. It's talk about fragmentation. Walk around this show, see how many operating systems you see on the floor.
Right.
So again, another embedded's been fragmented for a long time. Right. I think cloud connectivity and wireless will force consolidation actually at the OS level.
Right.
So you walk around and you have the old ones and the more established ones like FreeRTOS out there, but you see Zephyr and you see a lot of other ones hanging around here. So for us and for our customers, the faster we can get them into OSs, the better, actually. And it's much more easy to secure a product running an OS than a bare metal implementation.
Green Hill Software is the worldwide leader in embedded safety and security. With the most safety and security certifications and the best track record for solving embedded problems, Green Hill Software has been leading the embedded world since 1982. For more information, go to ghs.com.